Okay, let me get this on the page. Here is lesson 7-7. I think the last video for this chapter, at least from the sections. This is example 4. We're going to be finding an inverse function. Here's our inverse function. And just like the notes, we kind of go through a stair-step process to answer each one of these questions. This is very heavy conceptually, and remembering the steps on your own to get the correct answers on the homework. But it's not really heavy math-wise. This lesson, and I'll say this during class, this is a precursor to some calculus stuff. And you need to be exposed to it, so that's why we're doing this now. So first of all, before we go off and try to find the inverse, we need to analyze the function and just think some common sense number stuff. What's going to happen to this function? So we can figure out the domain and range. Remember, the domain is a set of input values and the range is a set of output values. So the domain is concerned with the x and the range, and this is concerned with the y's. This is another phrase for y. Y equals 2x squared plus 2. These mean the exact same thing. So when I look at this right here, let's just look at the top one. Is there any problem with putting in x's? Does anything bad happen? Do I get plus or minuses, or do I get divided by zeros? There is no restriction on any x. I can choose any positive or any negative number up and down the whole real number line. And so that means our domain is going to be all reals. And that's a little script R for all reals. But whenever I put any numbers in for these x's, what's going to happen? Any number, positive or negative, squared is going to be positive. So I'm going to have some positive number times 2 plus 2. So you got to think to yourself, well, there's going to be a restriction on y. It's always going to be positive, right? And it's even, I can even restrict it further than that. Let's say x is 0, and this gets covered up. What's the smallest value that y can be? Well, the smallest y can be is 2. Any other number I put in here is just going to make that bigger. Plus 2 gets higher from there. That's the kind of logic you need to go through figuring out these domains and range. So we're going to say the y have to be greater than or equal to 2 there. That's our domain and range for the function. The good news is those are the exact thing as the domain and range for the inverse, just swapped. And we'll figure that out in a second. Now let's do our x and y thing, swap those to find the inverse. So we have x equals 2y squared plus 2. We have to isolate y, do all inverse operations in reverse order. So first we're going to subtract the 2 to the other side. It becomes x minus 2, and that's 2y squared. We need to continue to isolate y. Divide by 2. So that's going to cancel that, and I'm going to switch the order here. So I get y squared equals this fraction. The last step is to take the square root of both sides. We do not have to rationalize, which makes it nice. So square root of anything squared, that thing just pops out, and we're left with plus or minus. Anytime you take the square root of the right-hand side, that's a good technique. X minus 2 over 2. Okay, now that's the inverse right there. We figured that out. You don't have to think about the domain and range again. All you have to do is change the letter. The range of the function is the domain of the inverse. So what is my domain for my inverse? It's going to be, just change the letter x greater than or equal to 2. And then what's going to be my range? Because we have this plus and minus, the range is going to be the domain of the function. So it's going to be y is all real numbers, or you can just say all real numbers. Okay, so that's it for the domain and range stuff. The hard part was done up there. Okay, the last thing is we have to decide, is this a function? Remember I told you before, when you get plus and minus stuff, that means bad. So this one is not a function.